Hi, we're going to talk about three topics with this video: accuracy, precision, and scientific notation. If we look at accuracy, accuracy is how close to the correct value the data points are. So if we're going to look at golf as an example, the hole where the flag is going to be the correct value. So when we hit our golf balls up there, that's where we want them to go in. So if we look at this picture, we can see that there's four golf balls. We have one here, 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 and here. And none of those four are very accurate. They're not close to the hole at all. So we have very low accuracy. On this next slide, we're going to talk about precision. And precision is how close the values are to each other. So it doesn't matter if they reach their goal. It doesn't matter if they get the hole in one. It doesn't matter if they get close to the hole. Precision is how close all of them will be to each other. So again, if we look at this, we see that we have our four golf balls and none of them are close to each other. So this is not precise. But let's compare accuracy and precision together. So looking at this picture, you can see that when we hit our golf balls again, that the golf balls are very close to the hole. Actually, one went in the hole. Okay, so they're all really, really close to the goal. So that makes this a representation of accuracy. And on the next slide, we can see that the next time we hit them, they all are almost on top of each other. They're at least touching, so this is very precise. We hit the ball in the same place 4 different times, but it is not very accurate because here is our goal. We didn't even get close to that, so these are not accurate. Now let's look at both accuracy and precision. Okay, so we look at this. Accuracy. Are these accurate? Did these four golf balls go to their goal? Okay, our goal is the hole where the flag is. Yes, they all went to the goal. So this is very accurate. Now, are they all close together? Yes, they are all close together. So this picture represents both accuracy and precision. Now, when we look at precision, we're going to measure this pencil using 5 paper clips. Now, these 5 paper clips, they're small, so we measured them with the 4 paper clips. Now let's look at the big paper clips. We've got 1, 2, 3 big paper clips. So here it took 5 small, or if we're measuring them with a different device, 3 paper clips. And pretty much everybody that looks at these is going to measure and say, oh, well, that top pencil is 5 small paper clips. Okay, so we're going to get very precise answers. But the question is, are they accurate? Well, this is going to depend on our measuring device. Okay, so it's not accurate, but it is precise because we pretty much get the same answers from everybody. Now, let's look at this one. We have a ruler here, and we're going to measure this, and we come up with 3 1/8 inch. Okay, so this is precise. A lot of people who are going to measure this are going to look, and you can agree, you look at that, and we're going to see that this is about 3 1/8 inch. So remember, precision are all of the answers about the same? Yes, they are, but it's not very accurate because look, there's a lot of space between each increment on this ruler. See, this is all space. The space between those 2 marks we just have to guess at, or between these 2 marks we just have to guess at. But If we measure it with metric on the other side of the ruler, you can see there's a whole lot of little marks there. So we can get more accurate. Okay, so if we measure the pencil here, we can see that it is 8.1 centimeters or 81 millimeters. Okay, this is both accurate and precise. So I'm going to ask you this question. How can the measurement get even more accurate and more precise? If you said measure something smaller than millimeters, like maybe nanometers, then you would be correct. Anything, if you just said something smaller than a millimeter, then you would be correct. Okay, now we're going to talk about scientific notation. Scientific notation is a way to express a number that is more accurate and more precise than just a decimal. Okay, so here we have an example of something that's written in scientific notation. Let me make that decimal a little bit bigger. Okay, 5.2 times 10 to the third. Okay, now we can express this as a long standard number. Let me show you how to do that. Let's take and write it down here, but let's add some zeros behind it. Okay, because this exponent here tells you how many places, how many times we're going to move that decimal. And if it's a positive number, we're going to move it to the right. And if this was a negative number, like we'll see in the next example, we'll move it to the left. But let's just concentrate on this example. Okay, so how do we write this as a standard number? Well, we're going to start here because that's where a decimal is now. We're going to move it how many places? 3. So that's 1, 2, 3 spots. So that's where our decimal is going to be in our standard form that we're going to write this. Okay, so this 5.2 times 10 to the third power is really 5,200 when we write that out. Okay. Now let's erase this and let's look at a different number. 9.65 times 10 to the negative fourth power. So the question is, how do we write this as a standard number? Okay, pause here on your recording and see if you can figure that out before I give you the answer. Okay, welcome back. Well, what we're going to do is, well, just a moment ago I told you if you have a negative exponent, you're going to move the decimal to the left. So what you should have done is take and write some zeros here and then put 9.65 because it's 10 to the negative fourth. So we're going to move our decimal to the left to get a standard number. How many times? 4. So here we go. 1, 2, 3, 4. And that's where our decimal is going to be for our new number. So our number is really 0.0000965. Okay? So if you remember just a moment ago, we had a number that was to the positive 3, and it was a large number. So let's go back and look at that. Okay, our first number was 5.2 times 10 to the third power. Okay, and that ended up being 5,200. Okay, and this is a large number. And the one we just worked out was 9.65 times 10 to the negative fourth power, which was 0.0000965. well, 0.0000965. Okay, and this is a very small, oops, I misspelled small. Sorry, I misspelled small number. So when the exponent is a positive number, you get a large number. When the exponent is a negative number, you have a small number. Okay, let's do some more practice. Now I'm going to do a standard number. You see if you can write it in exponent in scientific notation. So let's do 78,000. Okay, how would you write that in scientific notation? Pause the video here and see if you can do that. Okay, welcome back. This would be, our decimal's really here. It's not written, but it's understood that if you don't see a decimal, it's at the end of your number. Okay, so 1, 2, 3, 4. We're going to move it 4 places. Okay, this is a large number, so it's going to be a positive exponent. Now, when you move your exponent, you want to move it so that you have one number, then a decimal, and either 1 or 2 more numbers, 3 numbers at the most. So this is going to be 7.8. You don't need to write the 0, times 10 to the, what do we say? 4th power. Okay, very good. So we moved our decimal until it was in front of the first number right here. And then we counted how many places we moved it, and that's our exponent. Okay, so let's look at another example. What if we had a very small number? Let's do 0.00053. It's a very small number. How would you write that in scientific notation? Pause the video. Okay, welcome back. We're going to move our decimal 1, 2, 3, 4 spots. Okay, so it's going to be 5.3, and we moved it 4 spots, and we moved it to the right. It's a small number. So our exponent is going to be what? Yes, you guessed it, a -4. Okay, now I want to show you one more thing, and that's how to how to multiply and divide numbers that are scientific notation. Okay, so first let's review our order of operations. Please excuse my dear Aunt Sally. Okay, so we're going to do anything in parentheses first, and then our exponents, and then multiply, divide, add, and subtract. So look at this number, 6.02 times 10 to the 23rd. It's a very big number. Okay, and let's multiply that by 8.65 times 10 to the 4th. Okay, so the first thing we want to do here is we want to multiply these two numbers. So let's do that real quick. Pause the video. Alright, when we multiply 6.02 times 8.65, we get an answer of 52.073. 52.073. Okay, now we're going to do times 10. And when you multiply two scientific notation numbers, you're going to add the exponents together. Okay, so 23 plus 4 is 27. Okay, so this is our preliminary answer. Now, why do I say preliminary? Because look at this number here. It's 52.073. And remember a moment ago I said in scientific notation, where do we want our decimal? After the first number. So we're going to have to move our decimal over one spot. And when we do that, we get 5.2073 times 10 to the, and we had to move our decimal to the left, so that increases the exponent by 1, because we only moved our decimal 1, 28. Okay? So there is our final answer when we do this problem. And that's multiplying scientific notation. Now let's do one where we're going to divide scientific notation. So 5.6 times 10 to the negative 18th. This time it's a very small number. We're going to divide that by 8.9 times 10 to the 8th power. Alright. Well, when you divide exponents, we're going to when exponents are being divided, we subtract the exponents. So for the exponents, it's going to be negative 18 minus 8. Okay, but let's go ahead and do this part of our math first. So 5.6 divided by 8.9 is 0.629. Okay, so 0.629. Okay, times 10. Okay, subtract these. 18 minus 8 is 26. Yes, negative 26. Okay, but is this in the correct form? Okay, look at it. If you said no, then you answered correctly, because this decimal needs to be right here. So we're going to have to move the decimal. And we're going to move it this time this way. Okay, so our answer is really 6.29 times 10 to the, we're moving the decimal to the right, so negative 27th. Okay, so this is our final answer. Okay, and if you need to go back through and review scientific notation, then you can just take the video back and go through these steps again.